So one of the things they want us to be able to do is graph a piecewise function. So I have two examples. This first video, this one, is an example in the book, and then I have a bonus one. So we'll talk about that in the next video. So it says sketch a graph of the function. Now you'll notice that there are three pieces. 1, 2, and 3 pieces. And each one is different. Okay. So you have to go by the domain and you have to go by the function, what they give you, what each piece is saying. So let's look at if x is less than or equal to 1. And so I'm going to consider a table of values here. X, f of x. And my f of x is going to be x squared if x is less than or equal to 1, right? Okay. Whoops. Jumping around on me. So I'm going to think of some numbers less than 1. I'll pick -2, -1, 0, and 1. Now, the 1 that we have right here, okay, so this input, that is going to be a closed dot. So you always have to consider what the end of the domain is. So in this case, we're saying all the numbers from -infinity up to 1, and we're going to include the 1. Okay? Now, we're going to take those random numbers that I picked. I picked nice little numbers here for x. They're all numbers less than or equal to 1, and I'm going to square them. So I get 4, 1, 0, and 1. Okay? So if you're curious what I'm doing, I'm taking -2 squared, and then the -1 squared, and then the 0 squared, and then the 1 squared. Okay, so I'm putting it in that function, the square function, because that's what it tells me to do if x is less than or equal to 1. Okay, so I can graph these points, -2, 4, and then -1, 1, and then 0, 0, and 1, 1, and I'm going to make that a closed dot. And then I get this little graph. It's kind of a U shape that looks like that. Now, how do I know it's a U shape? Well, it's the toolkit function. It's the square function. So it should look like a parabola. Okay. Now it stops at 1. Don't continue it on because then you're getting into the next domain. Okay, so I'm going to switch colors. And I'm going to go to the next domain where it's 1 is less than x is less than or equal to 2. And then I'm going to make a table of values for this section. So I'm going to have x, and then I'm going to have f of x, which is just 3. Now that's the constant function, right? So I can pick numbers between 1 and 2. I don't know, 1, 1.5, 2. And I'm always going to get an output of 3. Now, before you're up in arms at home when you're watching this, what about the 1? And you might be saying, well, you can't include the 1 because it's got to be greater than 1, right? Okay, and you're right. X has to be greater than 1. So what it means is it's going to be an open dot. So you have to consider there might be an input of like 1.00007. Well, that would be a number greater than 1 and less than or equal to 2. So I can't list all those numbers between 1 and 2. So what I have to do is I have to say I'm going to stop at 1, but I'm not going to include the 1. Okay? Now, that might be one question you had. What's the output? The output is 3 every time. It's the constant function. Now I can graph these points. I do 1, 3. I'm going to put an open dot there, though. I can't have it be a closed dot, then it wouldn't be a function, right? It wouldn't pass the vertical line test. And then I've got 1.5, which is like in the middle there. And then 2, 3, which 2, 3, that is a closed dot, by the way, because it says equal to, less than or equal to 2. Okay? So it's just this little section right in there between 1 and 2, and it's just kind of a flat line, an open dot on where the 1 is at the point 1, 3, and a closed dot at the point 1, 2. You have to be really careful with drawing those because you don't want your open dot to look closed. So I kind of have to make it big. Okay, that would be the second piece of the piecewise function. Now I'm going to use a third color to do this last piece. So it says if x is greater than 2, so I'm going to think of numbers greater than 2. But here's the thing. I have to use 2. Okay, so always remember that you have to use those endpoints, because I might have a number like 2.1 or 2.001 or something, and I have to consider those. Now, because I'm not including the 2, x is greater than 2, this will be an open dot. Okay, so sometimes students have a tendency to skip over the numbers, like they just want to go to 3. Well, what about all those numbers that are between 2 and 3? So that's why we have to use those endpoints that they give us. Okay. And then what's the output for all of these? It's just going to be x. Okay, now I have to do more than one number. So 2, 3, 4, that's enough. And the output is x. This is the identity function. So 2, 3, 4. Okay. All right. So these are a little confusing. I'm trying to give you a minute to let it digest and sink in. You can always rewind the video and watch it again. Now we're going to graph these points. Now, there's no end. It goes off to infinity, right? Okay, so these, I'm not going to continue my table of values, but it keeps going. So we'll have an arrow at some point. Okay, so where is the point 2, 2? It's an open dot, and it's right there. It has to be an open dot because otherwise it wouldn't be a function. It wouldn't pass the vertical line test. Then where's 3, 3? And then 4, 4. And so we're getting a piece that's going off like this. Okay? Now, you can do it all in the same color. I just used different colors so you could see which piece was matching to which. And I like doing these. They're kind of funky, you know. They look a little weird. They're not your typical functions. So, but I think that makes them exciting. So you can see there's 3 distinct pieces here. They don't connect. You know, sometimes they connect, but this time they don't. Okay, so that's how you sketch the graph of this particular piecewise function. You take each piece individually. You always have to consider the end points, whether it's an open dot or a closed dot. Okay? All right. Good luck with that. But there's another video.